Alright guys, today we're going to be looking at the binomial theorem and Pascal's triangle. Let's take a look at this problem right here. If I told you to multiply or simplify x minus 5 squared, what does it mean literally? Well, x minus 5 squared literally means x minus 5 times x minus 5. And then you would just simply FOIL this out and get x squared minus 5x minus 5x plus 25. Add your like terms, you get x squared minus 10x plus 25. Not that challenging. However, what if I ask you to do x minus 5 to the 5th? Well, if you expanded this binomial, then what you would have is x minus 5 times, and that would take a pretty lengthy time to multiply that all out, which is why we have something called the binomial theorem. Now, in order to use the binomial theorem, we have to know what Pascal's triangle is. Pascal's triangle was developed by Blaise Pascal, and it starts with the number 1, and we call that row 0. Then it's 1, 1, that's row 1. Notice Pascal's triangle always starts with a 1, and it always ends with a 1. The first and last numbers in each row are 1. Now, beginning with the second row, every other number is formed by adding the two numbers immediately above the number. So, for example, this 1 plus this 1 will give me a 2. And then to get this number in the next row, I'd add 2 plus 1 and get 3. For this number, I'd look above it. 2 plus 1 is 3. And then to get this number, 3 plus 1 is 4. 3 plus 3 is 6. 4 plus 1 is 4. 3 plus 1 is 4. And then 1. And you can continually do this, and then that's where Pascal's triangle comes into play. Now, we're going to use that to solve problems like this. Like, say, for example, I want you to do x minus 2 to the 4th. Well, my answer is always going to have one more term than the power. So since this is a power of 4, my answer is going to have 5 terms. So 1, 2, 3, 4, 5 terms. I'm going to look at Pascal's triangle. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And remember, this is row 0, row 1, row 2, row 3, and row 4. Since this is a power of 4, I'm going to use these coefficients. So I'm going to have 1, 4, 6, 4, and 1. What I'm going to do next is I'm going to look at the second term. My second term is negative 2, and what I'm going to do is I'm going to go up in power with them. So I'm going to do negative 2 to the 0 power, negative 2 to the first power, negative 2 to the second power, negative 2 to the third power, and negative 2 to the fourth power. And then I'm going to take my first term, which in this case is x, and I'm going to go down in power with that. So x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. I'm going to evaluate the first part of each term. So 1 times a negative 2 to the 0. Anything to the 0 power is 1. 1 times 1 is 1, so 1x to the 4th. Negative 2 to the 1st times 4 would give me negative 8. Negative 2 to the 2nd times 6 would give me 24. Negative 2 to the 3rd times 4 would give me negative 32. X to the 1st. And the negative 2 to the 4th times 1 would give me positive 16. And remember, anything to the 0 power, so x to the 0 power is just 1. So 16 times 1 is 16. And there is my answer. Notice that this is a quintic polynomial, but that is my answer. All right, let's take a look at one more. Let's say I give you x plus 5 to the 4th. Again, look at your power. My answer is always going to be one more than the power for the term. So 1, 2, 3, 4, 5. I'm going to look at Pascal's triangles again, and then I'm going to look at my row 4, which is these sets of numbers right there. So that'll be 1, 4, 6, 4, 1. I'm going to take my second term, which is 5, my second term, and I'm going to go up in power. So that'll be 5 to the 0, 5 to the 1st, 5 to the 2nd, 5 to the 3rd, and 5 to the 4th. I'm going to take my first term, which is x, and I'm going to go down in power, so x to the fourth, x to the third, x to the second, x to the first, and x to the 0. And then I'm going to clean this up, and so 1 times 5 to the 0 just give me 1, so 1x to the fourth. And then 4 times 5 to the first to give me 20, so that's 20x to the third. Then 6 times 25, that's going to give me 150, so 150x squared. And then 5 to the third times 4, that will give me 600, so 600x. And then 5 to the fourth, they give me 625. And remember, anything to the 0 power is 1, so we don't need to put that one. And so there is my answer, which happens to be a quartic polynomial. And I'm going to go back, because I think on that last one, this one should also be a quartic polynomial, since it's a degree 4. All right, let's look at one more. So x minus 3 to the third power. So I'm going to have 4 terms, because it's always one more than the power. I'm going to look at Pascal's triangle, and this time I'm going to look at the third row. So this is row 0, row 1, row 2, and row 3. So those are the numbers I'm going to use, 1, 3, 3, 1. I'm going to take my second term, and I'm going to go up in power, so that'll be negative 3 to the 0, negative 3 to the first, negative 3 to the second, and negative 3 to the third. And then I'm going to take my first term, and I'm going to go down in power. So that'll be x to the third, x to the second, x to the first, and then x to the 0. And now, plug it in the calculator, you should get 1 x to the third minus 9x squared plus 27 x to the first, and then at the very end, plus 81 minus 27, and x to the 0 just goes away. And so then that leaves me with this, and it is a cubic polynomial. And that's it for today's lesson.